So in the early days, we were simply trying to determine what would be a functional way to search for planets going around other stars. And we hit on the idea of watching the diminution in starlight as a planet passes between us and the star that it's orbiting around. And then several proposals later, this mission got accepted for flight. It actually flew about 2 years ago, and we've been taking data since a few months after that. This is all about us, right? People think that it's about other planets, but it really is us trying to understand ourselves. And we're interested in life. Life is the exciting thing. So we're looking for planets that are not too warm, not too cold, not too big, not too small. And so that's the Goldilocks part of the scenario. We found a lot of planets that, or at least planet candidates, that are on the boundaries of those regions, and that's what the announcement on Wednesday is going to be all about. Well, we think that life, at least as we understand it, requires the presence of liquid water on the planet. And so if it's too hot, all the water boils off, and you have no water to make life with. If the planet is too cold, the water freezes out, and you never see it as a solid. And in fact, in our own solar system, Mars and Venus are examples of those two cases. Mars is essentially frozen now. You don't find liquid water there. Venus is much too hot on its surface to have liquid water. It's basically all boiled off and vanished from the atmosphere. So Kepler looks at a piece of the sky that's about as big as your two hands held out at arm's length. It covers the same area of the sky. And inside that piece of sky, there are about 2.5 million stars that are bright enough that Kepler might be able to look at them. But because of bandwidth limitations, the fact that the satellite is so far away, it can only send down information about a few 100,000, 1 or 200,000 of them. And so we have to pick 150,000 stars out of 2.5 million to look at. And the purpose of the Kepler input catalog was to characterize all the stars that we could see down to ones as faint as Kepler would look at, and decide which ones would be useful targets. So that was a long, ground-based observing program, a sort of mapping out the territory before we decided to go look at, inside this apartment on that block or something. That's the kind of idea that we had. So when the information comes from Kepler, what we find is stars that are likely to have planets because we see a dip in brightness that could be caused by a planet passing between us and the star. We don't know if those planets, those stars, actually have planets though, or if we are being fooled by other astrophysical things, such as stars going in front of other stars. Those are the most common ones. So our job is to follow up the Kepler discoveries and determine which ones are really planets and which ones are something else. There are a number of ways to do that that can be pursued with ground-based astronomy, and so